Hello, hello. Welcome everyone on the next DevOps Playground. I hope you can see and hear me well. Uh, well, welcome every regulars, and for those who are new, a few words on what we're actually doing here today. So on the DevOps Playground, it's our monthly meetup, which is organized by the ECS Digital. Normally we hosted it in our offices with some pizza and beers or other drinks. We try to share some of our knowledge from the DevOps space, play around with some new technology, and give back to the DevOps community in London, Edinburgh, but now online, also to the wider audience. We will provide. We're trying to stick to the hands-on format. So I will just talk briefly about what we're going to cover today and why we're going to cover it. But most of our session will be purely hands-on. There will be a lab environment prepared for everyone who joined our meetup on our meetup page. If you forgot to do that, please feel free to ask our support team in the video chat. They will try to help you and assist you. What we're going to cover today, we're going to talk about, well, we're going to build some cost-efficient project in AWS. We're going to use Terraform for that. I was a little inspired for this topic by working as a DevOps consultant. I've seen a lot of projects, a lot of usages of the cloud, and I noticed that a lot of times we're reaching for the solutions which might not be really the best for us. So I hope we'll cover something interesting. Moving on, just quickly, for those who are not as technical and haven't been around the cloud in general, a quick introduction on what it actually is. We're trying to keep those sessions open to everyone, so no previous experience is actually needed. So even if you've never seen anything, you definitely have seen something deployed into the cloud, but if you haven't played with any cloud provider, it should be fine too. So this is the definition I stole from AWS. But I'm trying to to not stick to such a firm definitions. But basically, it's a cloud is mostly built of Linux servers. It's a lot of data centers wrapped up in a nice API, and you can buy the servers or capacity of storage capacity, networking capacity, basically in the real time. Why would you do that? Why the cloud is such a buzzword? Elasticity, something which Amazon is talking a lot about. Basically, we can be way more responsive to our customers, to whoever uses our application, our services, instead of, let's say, stick to the firm schedule purchase orders for our infrastructure and always being slightly behind the curve. We can respond to that red demand curve a little closer with the way the infrastructure in our cloud could be organized with auto-scaling groups, reacting on the traffic during the day, not the next month if our product is getting more interesting. Agility, and this is something I personally like about the cloud. The ability to experiment if we need to test if, let's say, our batch will be more efficiently processed on, let's say, 100 nodes cluster. We can do it. We can spin it up. We can bin it, pay for what we used. So we can experiment very, very, very easily. And this is something a lot of, let's say, big names were benefiting in the beginning of the cloud. As you can you've probably heard of Netflix, among many others. And then lastly, the cost. Well, obviously, all the businesses are about money. If you do the cloud right, that could be very cost efficient because of that flexibility of this responsiveness. Nevertheless, if you just leave your resources idle running constantly, probably won't be the best cost saving initiative, but we'll get to that later. On like usually when we touch on cloud, there is a discussion on what's the best in cloud, what cloud provider how you should use. I think you should use the one which suits your needs rather than go for AWS is the best or Azure is the best or Google Cloud. This really depends on the use case. The offering slightly differs in, let's say, in the core functionality. They are very similar. There are also other names apart from the big three, but we're going to use the AWS on this project mostly because we use AWS for our day-to-day development and DevOps Playground, and it kind of came handy, but it wasn't any strong preferences to achieve what we need to achieve. Most of the services which we're going to use will have an equivalent at other cloud providers. And well, next we're going to stick to infrastructure as a code. What is infrastructure as a code is one of the DevOps philosophies or methodologies, approaches. We're trying to keep our infrastructure versions with our code, so we can keep track on what's going on in our house. It's pretty easy to integrate with CI/CD. Mostly because I generally use quite heavily Terraform. Decided to use it in our use case. Why? I like how our configuration is transparent. It's easy to automate, tear it down, bring it up. It's consistent, it's quicker, and for the business use cases, like if you stick to the principles in the right ways, also removes a lot of management headache and obviously saving some money. End of the day, usually business is all about that. And lastly, what we're going to build today, we'll go through some user stories, we'll go through some use cases, and we're going to build the service of that shape. So we'll have some Route 53 records, some static content, there will be some API gateway, there will be some backend running in our lambda function, and there will be a DynamoDB database, that's a NoSQL database. Basically, our users will be entering our simple website. They will see the content from the S3 bucket. Once they post the request, that request will go to our API gateway, which will trigger our lambda function, which, using the data from the user, will perform a database query. Database query will come back to the lambda function, API gateway, and will be displayed asynchronously to the user. So this is our aim. We'll go gradually. We won't do everything at once. So let's move on to what we're actually here for and our hands-on session. So firstly, about the configuration and the layup. So we are providing the credentials for everyone. You should see in the description, a video description, there will be a link to lab.devopsplayground.org. And then you need to provide your meetup username. So like for those who joined, for instance, in Edinburgh, that will be your meetup username. Sorry for naming you Matthew. It's a public list on the meetup page. So for me, it will be Patrick Pilecki. I can submit, and you should get a link to your workstation and to your IDE. As you can see, this is the same, just a different port, and your password and your username. So here is my Funny Panda. I will just reload it. So I would advise you to have one tab with our terminal, one tab on pod 8000, which will be our Visual Code Studio. It will include all the labs, and we'll have a skeleton of what we're actually trying to achieve. There is also a link to the documentation, which will include steps where we're going to perform during our workshops. So I'll have them, let's say, in different tabs, in different windows, and I'll go between those. So this is the way I like to organize my work. I tried to have it on both sides of the screen, but it seems to be too small on the YouTube sometimes. So I'll go that way, but whatever is comfortable for you. So let's go to our very first use case. We'll be deploying a static website to S3 bucket. S3 bucket is a Amazon block storage. It's well, one of the most popular products on Amazon. It's fairly cheap and easy to use. And we've got our first user story. Hello, DevOps team. We're working on some great idea. Marketing team already promoted, but we need to let's see, upload the front end team work, so the link could be accessible by the customers. So that's like a very simple task to do. So we just need to upload some HTML file. We don't know much of what's going further, so we can use S3 to do so. Basically, if we'll have a quick look on our lab, there is a content directory. Generally speaking, it will have what we're going off from our virtual teams to work with. This is, as you can see, very simple HTML file with some graphics. Nothing really special about it, and we're gonna well, make it available to the customers of our virtual enterprise. So our very first step will be to create S3 bucket. So let's grab this piece of code and go to our lab1 directory and main.tf file. So in our editor, it should be about here. We can paste it. Quickly, what's going on? We just create a bucket of the certain name. This is an important part. This name needs to be unique across the whole AWS. So this is not this name not only on the account we're using, but also across whole AWS organization. We're going to put it in the public access control list. We're going to put there a website, which will default to our index HTML, and we're going to add the tag that the bucket is managed by Terraform. Obviously, we can do way more with the S3 buckets, so usually try to add the documentation to the Terraform at the very bottom. So as you can see, even from the Terraform documentation, and I encourage also to have a look around AWS, there's way more parameters we can set up. Among most popular will be logging, versioning, or the policy on who can access the bucket. It has way more, let's say, to offer than just a static website's host, but that's what we're going to do in this part. So let's move on to our next bit. So this part, very crucial. We need to grab this little piece of code and go to our variables.tf, and we'll need to change this value to our panda. If you're still thinking what on earth is my panda, you can see in your URL to your instance, you've got a prefix. For me, it will be funny panda. For you, it will be proud, grumpy, sweet. But let's keep this different. Let's not try to use someone else's panda. because we might have problems to, for instance, create that S3 bucket or resources along the workshops. Just one more thing which I missed for the introduction in terms of the setup. Our instances have Terraform installed. The credentials for AWS are provided by with the instance role, so we don't need to configure anything further. We'll be able just to run it, but we'll get to that in literally a second. So we've got the S3 bucket, so we've got the place to store it. We know it will be serving some website. Now we need to just upload those files we're going to use. So again, this will be fairly straightforward. We got a resource called S3 bucket object, and we're just going to upload the files from the directory. So let's grab this piece. We will be building on our main TF, so we'll chuck everything here. So maybe it won't be it's definitely not the best way to organize your Terraform code, especially with the bigger chunks. But just to be easier to follow up on those workshops, we'll stick to this main output variables format. But let's say normally we would probably eventually build some modules or at least divide the configuration to the smaller chunks. But last thing before we're gonna actually start deploying things, it's good to have meaningful outputs of our configuration. So we want to know where our website actually is. So we're going to call our S3 bucket for that information. Just on this bit, if you're using Terraform, and again, I know it's not Terraform workshops, but the documentation on Terraform is really, really good. Whatever inputs we have, we got listed here, but we also have something called attribute reference, and we can see all the, let's say, values of the created resource we can call and use further in our configuration. So let's get our output here. So we need to have 3 files. First one with our S3 bucket and S3 bucket objects, output, and variables with your Panda. So this is a good start. We're starting to go somewhere. So now let's go to our terminal. And this will be a tricky part. I probably should be better in documenting that, but we need to move to our repository on the instance. So once you log in, you should see a work there. That will be our working directory. And then there will be a very long directory, but if you type H and press tab, that will be the name of our repository. And then we can move to lab number 1 to move to the workspace we are actually modifying. So you can see if we list the files, I've got more or less what we have in our code editor. So this is the path where you need to go to actually perform the commands from the README. So lab 1 directory, once we're there, we've got Terraform init. Apologies, I lost my window. What it's going to do, it's going to initialize any providers we're going to use. So it's going to download some stuff to this directory, as you can see in .terraform. Terraform, let's say, discovered that it will be an AWS configuration. So it downloads our provider to .terraform directory. Once that is done, we can, let's start with the plan, see if our configuration is more or less what we're about to achieve, or what we want to achieve, and we can see that those 3 resources will be created if we apply that configuration. So let's go ahead and do it. So Again, very first step, but we need to start somewhere. Okay, so I can see some questions, but I can see the support team is on the case. Apologies for trying to keep up with any feedback. Okay, so we've got our S3 bucket created. We've got some website URL, and that should be more or less what our beautiful front-end team treated us with. And there you go. You should see a familiar panda, a random date when I was working on this template. Apologies for that, but in the grand scheme, pretty accurate if you go through the README further. So first success, we managed to deploy something very simple HTML website, but we need to start somewhere. So let's go back to our README. We went ahead and applied it. We've seen our beautiful website. It's going well. And nevertheless, we've got yet another requirement. The URL is too long, doesn't fit the business card, and we need to do something about it. So we are blessed in this case that we already have a hosted zone in Route 53 called DevOpsPlayground.org, which we can use, and we can create the DNS record pointing to our website within existing hosted zones. So just to give you a gist, this is the account here. Oh well, this was the account here. We're working on it, but I can re-log in quickly to our AWS account, and just to show you what we're actually doing. Apologies, we're using SSO, so my session expired on the account, but before this lab, we already had the Route 53 zone created for us, DevOpsPlayground.org. So that's what we're going to be using in those labs. So let's go back to our code editor. In our main.tf file, we're going to use a data source. So we're going to call our AWS account to get the zone to get an object with the information about the zone, the hosted zone, with this name. Then in our next step, we're going to create the record. We're going to call that object. So as you can see, AWS Route 53 zone pane for the zone ID, and within that zone ID, we'll create a record called playground-mypanda. Just bear in mind to keep those names as they are suggested, because if you change those, you might lack permissions to actually create the resources which are needed. It's going to be a CNAME record, and it's going to point to our website endpoint from the S3 bucket, which we can already reference because we created in the previous step. So let's grab our Route 53 record and add it to our configuration. And as you've probably seen, we also want to see our fully qualified domain name once the configuration is applied. So we also add it to our outputs. So let's go over here. Right, we've got all the configuration from our steps. Let's go ahead and apply it, see if it works. We don't need to initialize anymore. In that workspace, we didn't add any new providers, so you can just go ahead and apply it. Should be just one resource, which is missing, which will be our Route 53 DNS record. That might take sometimes a minute or two, but let's hope it will be fairly quick in our case. And in the meantime, I'm just looking on the questions, but I can see that Boris is helping everyone. Thanks a lot, Boris, for that. Like I said, well, should be with us shortly. It might be also that if we all create the DNS records now, I might be hitting some throttling, but let's give it one more minute and probably notice that I'm not the patient one. There we go. We've got our new Route 53 record. So let's have a look if it works. If our product manager, product owner, or whoever you're scared the most could feed it on the business card. And there you go. Our DNS record is created and is pointing to our S3 bucket. You could probably notice that the connection is not secure, so we don't have any certificates for this particular record. It is possible to let's say points to the static content in S3 and also apply the certificate, but that would require CloudFront distribution and a little more let's say sophisticated configuration. For this use case, well, we're going to skip adding certificates, especially in the light of two previous playgrounds heavily focused on the certificates and how they work. And obviously, as you mentioned, it would be nice to now wrap it into a module, but we won't be doing that today. So we've got our website deployed. It's a good start, but I wouldn't be impressed if I were you. So let's destroy this configuration in this lab and move to the lab number 2, where the things will start getting a bit more complicated. So in our lab 1 directory, let's execute Terraform destroy. That's the beauty if you use infrastructure as a code. Like, we can create quickly, we can destroy quickly, and we're not really attached to our infrastructure. So we treat it more like a cattle rather than a pets, if you like to follow those analogies. Cool. So let's destroy that. Should be quick, but our record might take a minute or two to be destroyed. And in the meantime, I'll jump to our next part of the README. We're gonna hit the lab number 2 now. Let's just see if we destroyed our record. Not yet. Well, let's come back to that in a second, and let's see what we need to deal with this time. Yet another message of our virtual private product manager. Hello, DevOps team. We promise to keep you on the loop, but things are going out of hand. The product which was announced will be finding your spiritual animal. It's probably awesome. Nevertheless, the algorithm, which was a sophisticated algorithm, which meant to find that animal for you, it's not ready yet. There is a Python function designed by the backend team, which could handle it for now. Well, it's not the best, but it's what we got, so we need to deploy it still without any budget for yesterday. Sounds like the DevOps day. So we've got some index HTML, but there is no API. There is just space for invocation URL. And we've got some Python function, which requires environment variable animals to be present to actually work. So let's have a look if our destroy was successful. So let's move to our lab number 2 directory, and let's move on the README, see what we got. So this is our static content. Again, we've got some simple stuff here, so async function, which is posting to some API which is not here yet, and it's drawing the response based on what once the function is successful. Fairly simple. The API, something we'll need to figure out. But what we can do right now, we can go to our variables and make sure that we got the right panda in our lab2 directory. So let's go ahead and see the variables. That should be funny panda for me, so I'll quickly change it. And we should see the configuration which we designed in lab number 1, and the outputs are already here in lab 2. So as you can probably guess, if you're not sure if you did copy paste or work your configuration right in lab number 1, in lab number 2 you've got kind of a checkpoint. The only thing which we need to remember is to name our panda. So we've got a different content in this part, but we'll get to that in a second. So let's go ahead and go back to README. So, well, we can basically deploy our front end even now. So at least that's what I was thinking the first time I was writing those workshops. And yes, please destroy the previous build before running the lab number 2. So I'm gonna do Terraform apply, Terraform init and Terraform apply on lab number 2. And that will basically deploy us the static file, which should not work, but it will be deployed and accessible. Again, it is something. So that will result in our playground funny panda being available. Nevertheless, the form which will be included should not work. But we're building gradually. So let's deploy that and have it ready. So we've got some Python function here. Basically, as you can see, it just grabs a random animal from the animal list and it displays it to the user. You can see the lambda handler here. This is basically by convention how you invocate your functions, how you start everything. Lambda functions interestingly support up to 4 kilobytes of environment variables in environment variables, but thankfully our animal list is only 3.1. Again, it probably is not the best way to, let's say, pass the application critical data, but as we're going to use lambda function to host our Python backend, so just to, as an example, though, that we can actually use the OS environment variables within the lambdas we added it here. So let's grab this one and go to our code editor. We actually already have it in our context. Never mind, sorry, I'm a little chaotic. What I actually wanted to do is to grab that link again and see what we actually deployed this time. So you can see that we used exactly the same code, we just deployed the different file. Nevertheless, we're getting this terrible error because our API is not existent yet. So we've got the front end, and now we're working on the back end. We've got this function, we've got those environment variables, and we want to deploy it somewhere which won't cost us money. So basically, we're going to use the lambda function. The way it works, you can execute your code blocks on like in AWS and provided environment. They support basic programming languages, but you can also run the functions on the custom runtime. They are generally short-lived, up to 15 minutes. You can throw up to 10 gig of RAM. Can chain them with the step functions. You can run a container. It's quite handy and really cost efficient in terms of pricing model. You pay for the second of per gigabytes of RAM you use, but the rates are well, pretty low. Is there pricing here? Well, I'll just out of curiosity, but yeah, 20 cents per million requests, and then 0.000 for every gigabyte second. It's one of the few services which rarely come on your cost report. So let's stop by waffling and add that Python function to our main.tf file. So here, quickly what's happening, we are using a new provider called archive file, which basically takes our Python function and zips it with the name of our Panda. It provides it to our lambda function resource. We will create a lambda function called Playground, our Panda. We're going to use a role which will be defined in a second. We're going to paste it in a second. And our handler will be app, like our app.py file, .lambda handler, which will be our function here, which are actually, well, start the magic with our lambda function. We're going to use 3.7 Python runtime, and we will need to provide some environment variable. Again, we're going to add some tag to the config. And this is again the important part. So we need to add the variable to variables.tf. So let me jump over there. Nevertheless, this is not what we're intending to have. We need to grab our magic list from animal list.txt. Thankfully, it comes as a comma separated string, so exactly what we need here. And let's pass it as a value to be in our environments. I used a map here intentionally. Like normally for our lambda functions, we could pass multiple environment variables. So it depends on what we're trying to achieve. So it's just a format which makes it a bit more future-proof. And lastly, every lambda function needs some execution role. So we need to add this one to the mix too. So this is a simple IAM role. IAM is the way we manage our permissions. One of the ways we manage our permissions in cloud. So we can create a role which will be this particular one won't have any permissions, but it will be assumed by one of the lambda functions. We will add some permissions to that role, which will allow it to contact our database later on in the workshops. But yeah, to create a lambda function, we need to provide the lambda role. Again, I encourage to have a look on the docs in the meantime. Like, there's way more we can pass to our lambda function, and we've got way more possibilities than this simple use case. And the documentation is pretty good, so probably worth having a look. Right, so we've got our lambda function, we've got our front end. Let's go to our let's make up an API and make those two working together. So we're going to use API Gateway. Again, it's this AWS managed service, as you can guess, an API service. Doesn't have any idle cost, and you pay for request, and the pricing model is quite favorable, especially for the small projects. So let's add it to our main.tf. I can see the questions. Cost-efficient infrastructure. Where is the cost comparison optimizing? So, well, what we're building here, we're building the infrastructure based on the services which are in on-demand pricing. So the idea here, like, we want to build something without any idle cost, leveraging the services which, well, AWS pricing model makes, well, let's say, cost effective, cost efficient. So I didn't go through I didn't want it to be a Amazon sales pitch, going through the pricing models. We just want to build some stuff, which which will be, let's say, our idea here will be without any idle cost. We will have a simple examples here, but obviously all those services are easily expandable. So trying to hit that sweet spot between more experience and less experienced users here. So I hope that answers the question, but happy to go further. I'm trying to look on the questions now and then. But moving on, let's go to our API. The next thing which we need to create once we already have an API will be an API gateway method, and it will be a post method. We don't add any special authorization there. Let's grab it and add it here. Once we've got the method, we need to also define the method response, which will be basically a template on how that method should respond to any request. This is one of the parts which is definitely more smooth if you do it through the console in terms of how we build the API than doing with Terraform. But well, let's stick with what we started. Next, we need to add an API gateway integration. So this is the part where we actually let our API gateway to invoke our lambda function by the method we just created. So let's grab it and add our integration. Apologies. And as you can expect, once we got the integration, we need an integration response. So we need to go yet again to our README. So just to recapture, we've got the gateway itself, we got a method response, gateway integration, and integration response. Once we got all this, let's go back to our README. We need to also add the gateway deployed API gateway deployment, which will make those methods available. Will be on the stage version 1. And then at the very last, we need to make sure that our lambda function can be invoked by API gateway. So we need to add the resource-based permissions. So in this case, I'll just go a little higher to our lambda function and stuck them here before the gateway. So that looks that's looking good. We've got our API. One more thing which we'll need to update, we need to pass the API gateway URL to our index.html file. So basically on our resource AWS S3 bucket object where we've got index.html, you can either grab this whole block or just this block where we're going to change source to the content, and we're going to use template file function, which is a Terraform function, to inject our API gateway invocation URL into our HTML file. So let's do just that. So this will, again, once our gateway deployment is complete, we can grab invoke URL for this deployment. And to accommodate that, just one little change to our index.html file. In the place where we had a SASE node from our frontend team, we just need to, in those both places, we just need to pass our URL variable, and we need to rename this file, save it as a TMPL. So this will be the template, which will be parsed by Terraform, and will include the API gateway URL, invocation URL. So that looks about right, and let's go and try to deploy it. We need to go with Terraform init again, because we have yet another provider to initialize for our lambda function. Once we initialize, let's go ahead and apply that, maybe without the typos though. Oh no, sorry. Cool. So we're going to add a lambda function. We're going to get the role. We're going to get an API gateway, the method, the integration, the response. All looks good. And our index.html will change to our template file. So let's go ahead and do it. That might take a minute or two, but we're getting there. So here we go. We've got our backend, API, and frontend. So it should work, shouldn't it? Well, it won't. As we can see, we're still getting an error, but we were expecting this error. So this is an interesting bit. If we have a look on actually what happens, we actually got an options request, which will be a pre-flight request. So if we have a look on our README, well, to support the operation we're trying to do with our API, we actually need to implement yet another method and allow the CORS requests which we need for our function to be triggered. Nevertheless, as you can see, the rest of it seems to be fine. If we nevertheless have a look on our HTML file, our API, well, actually, I might as well see it here. You can see that our API is actually getting called. It's just the response. It's not like we planned. Quickly, I'll go to our AWS account just to show you what we are actually doing from a different perspective. So this is my Funny Panda API. We've got our post request, and you can see familiarly method request and response, integration request and response, and our lambda function. You can see that the ID here will be matching the ID from the request. So everything looks good, just the missing options parameter. And we can even go as far as to our lambda function. Let's see if that one is deployed as well. Here it is, my funny panda. It seems to be here. Our API gateway trigger is here. And if we want to, we can even quickly give it a test. This is the payload we expect. And we should see that our animal is returned. So the only part which is missing is that options method, which we need to add to our API gateway. So it's very similar to what we've seen before. It's the gateway method response, integration response. So I won't be spending too much time on this again. Let's just grab it and paste it to our configuration. I'm not so good at copy pasting, as you can see. Oh well, step by step then. Apologies for that. I guess that struggle wasn't super entertaining, but we're getting there eventually. So our main TF, let's just at the very bottom add our options request support. So once we added methods and responses and integration, the very last step is just to replace our gateway deployment resource with the new version, which will include the newly provided methods. So let's just go back to the gateway deployment. So we're on lab number 2 currently. Oh, and I'm making changes to lab number 2. Well, that was reckless, but that's fine. We're going to be growing gradually anyway. Good spot. So let me just do a little cleanup before I get lost in my own code. So we're on lab number 2. And we've got our methods. We need our options, which I missed. So we got our options method response, integration, and yet again I need to grab the last method. Apologies for being a little chaotic here. Am I copying and pasting the same stuff twice? So API gateway, that's okay. Gateway methods, gateway integration, response, integration response, options method, options. Yeah, I pasted it more than I should. It's okay. Sorry, I got a little chaotic, got lost by one of the questions, but Not your fault, it's just me. Cool, so we've got this, we've got that. Just on our gateway deployment, that's class. So that's where we should be. Okay, well, so let's go back to our config, go to our terminal and see Terraform plan. Whoa. So I did a little mess in my main.tf file, clearly, by adding something. Adding a lot of stuff, unfortunately. So let me do just a quick cleanup. As I mentioned, we can always rely on the next lab as a source of truth. So just go back to what we actually need. Spawn integration item. Okie dokie, so that should be almost it. Apologies here again, I got a little lost. I opened two files for the lab number 2 and lab number 3 and got them confused. That should actually so I still got some stuff being twice. The gateway method response, integration response, lines 199. Oh, okay. Well, I put it again to. Apologies for being extra messy. Response item, that's class. So now in our plan, we should have five to add, one to change, one to destroy. That's about right. So we're going to put the new, changed our index. We're going to add the options methods, and we're going to recreate the deployment. That looks about right. We can apply that and finally see our service working to some degree. Cool. So that was applied. A bumpy road, but live coding happens. So let's have a look on our service. And we can see our spiritual animal now. Splendid. So for me, I'll be probably a teal, whatever the teal is. So we can see now that we're getting positive response and our request is actually processed after updating our API. Cool. So that's what we wanted to achieve in this bit. We've got our static front end communicating with our serverless lambda backend running Python function and giving us response. Well done. So we're not getting attached to our code nevertheless. Let's go ahead to our terminal and do a brutal destroy yet again. So that will take a minute. I managed to click on something in the meantime. So let's remove our 17 resources and move to the next lab when our project is surprising us yet again. So in this part, we're reaching even further. Like if you remember our diagram, we need to, or we're going to go to as far as the database this time. Our product owner messaged us yet again. Everything is great. Nevertheless, someone find out that our service is actually a little phony. You can type your name. Well, it's not here. It's just got destroyed. But you can type your name a few times, and you're getting the same animal. Doesn't look credible. We need to do something about it. So we don't have anything serious to be implemented in terms of so sophisticated algorithms predicting your spiritual animal. So we're just going to be cheeky, and we're going to implement a simple DynamoDB. We're going to create a DynamoDB table. DynamoDB is a NoSQL database. Again, managed service. You provide you create the tables. You pay for reads, writes, and so on. It comes pretty handy. What we're going to do, if once someone is using our service, the name will be put into the database. If someone will try this name again, then we'll get the same animal. If it will be a unique animal, it will go to the database. So just on this bit, I'm just going to make sure that, generally speaking, if you weren't as messy as I was with your lab number 2, the lab number 3 should be what you actually should have as lab number 2. I did a little mess here, so I just paste the content from lab number 2. But if you haven't edited this file, this should include the steps from lab number 2, and we're now moving on to lab number 3. Our destruction was successful, so I'll just change the directory to lab number 3. Cool. And let's have a look what we're actually about to do. So back on our documentation, we're going to create a simple DynamoDB table. We're going to call it Playground, and our Panda. Our hash key will be users, so that will be the element we can search the table for. We're going to use this as a certain billing mode. We're not going to stream it anywhere. Then our basic attribute will be a string in the users table. We'll add some tag to our table as well. Generally, a good practice to add the tags to your resources within AWS. So let's add this to the bottom of our main TF file, our table, and just so you won't forget, let's also go to our variables .tf and update the variable myPanda with your panda. So it will be a funny panda for me. Cool. Once we got our table, we'll also need to create a policy, IAM policy. I mentioned before that IAM is the way we manage our permissions, and one of the ways we manage our permissions on AWS. So we will create a policy which will allow to operate on the database, on the particular table we're going to create, and then we're going to attach this policy to the role we created for our lambda function before. So I'll grab this bit and let's go to our main TF file. I'll add it right after the role, so it's at least in the same and more or less the same space. And let's go to our attachment. So that would create our DynamoDB table. So we've got some database, pretty like DynamoDB as a service. I don't need to spin up the database service server itself, pay ridiculous amounts for replication and so on. It just works out of the box. Nevertheless, we need to make our function aware of that database and use that database. So we're going to use the bot03 for that. It's a wrapper or a package for to use AWS. Our function already have the permissions to use the table we're going to use. So quickly, what we're doing here, our previous function ended more or less here. We just added check user function, which will see if there is a name in the payload. If the name is in the payload, it will search for this table. And here again, once we copy that, please change it to your Panda. So if you want, it won't work. It's trying to get a user. If that was successful, then the response is the user, the animal which was already assigned to the user. Nevertheless, if the user is not existing, the random animal is assigned, and the add user function is executed, which basically will add the username and the animal to the database. So like a very, very simple operation. Again, the DynamoDB supports way more data structures, and it's way more complex. Like I said, within the cloud, everything works as a big API, so we can set the triggers on the tables that if certain data appears to the tables, certain events are triggered. Let's say follow further into the event-driven architecture. But we only have, well, an hour today, so we're not going to be designing every service possible and using every service possible, but just trying to make something work. So let's grab this Python code and go to our lab3 content. We'll need to slightly modify our function. So let's go to lab number 3, variables changed. Well, should be a funny panda. And then our function, let's replace it with our new version. So we've got the DynamoDB table, we've got the role for our lambda function, and we modified our lambda function so it can actually work with the database. As we moved to a new workspace, we need to initialize again, download all the providers, and let's see what we got this time. So let's try and apply that configuration. "20 resources" looks about right. Let's go ahead and apply it. That will take us probably a minute or two. It's going along. Oh, I can see AWS CDK easier to code than HCL. I actually wanted to touch on that. It's a good spot. Like, I used Terraform for the past 2 years, and I kind of got used to. But anyway, like either if it's just a CLI, maybe CloudFormation, or anyway, which feels good to you, I would say it's good. It was just a personal preference, so I dragged you all through the Terraform. I find it fairly easy to read and nice to use, but yeah, there are also good tools on the market. So we're still creating our Route 53 records, but we should slowly have it ready. There we go. So our service should be up and running. We should be able to go to our funny panda this time. And let's see what mysterious animal name I'll get this time. I got null, which suggests me that while I was preaching to everyone to change their panda names, I didn't do it myself. And this is what you get for not following your own instructions. So let's fix that. As well, our function is trying to look for the wrong table and it's not getting the right response. So I will reapply it. And this is a nice bit where you can see the advantage of storing your code with your infrastructure, because we are zipping that function and before passing it to the Terraform resource, any changes to the code will automatically trigger the change in the hash and our function to be redeployed. So let's do that and update our lambda. And now once we get to, let's open a new tab so we don't have any caching. Our funny panda. And let's see what the funny panda has for me. So it's Ray. If I'll try to find an animal for Boris from the support, it will be eagle. If we'll go back to myself, again it's Ray. So we can see that the customers looking for the spiritual animal won't be fooled anymore. We achieved great success, and we actually managed to send our request through the lambda function to the database and get appropriate response. Just to give you a look on the DynamoDB itself. So in our AWS account, you can see that our pandas. So in my funny panda, there is me and Boris, and we have our animals assigned. So our request went through to the database, and now depends on if our query is matching the database or not. We're getting either animal from the table or the random one. Cool. So I hope that works for all of you. Error pop up from lab 1. Any plans to make an event on integration Terraform into CI/CD pipeline? We actually had one. We had one in November. Richie was running a playground with Jenkins and Terraform. But we might think of something in the future as well, in terms of playgrounds on CI/CD. Yeah, in terms of our workshop, sorry, I'm looking at the questions, but I didn't really wrap up. That was the very last step. So we managed to build like a 3-tier app within an hour, and the idle cost of this solution is non-existent. We're only paying for what we're using. We managed to respond to, let's say, extortionate or at least strange requirements in a quick manner, and we managed to do a reusable configuration. Does anyone has any questions? I'm happy to address it. I was trying to peek on the questions in the comments on the way, but yeah, if there is anything else I can help with, I'm more than happy to answer that. Oh, I can see someone from November on our chat. That's nice. Yeah, I hope I was almost as good as Richie with my playground, and I hope that you all learned something. I will keep looking for additional questions. Uh, but once you finish experimenting, I would kindly ask you to go ahead and do Terraform destroy. Nevertheless, if you want, we'll clean the account. It's just a good practice, especially if you use your personal account for some projects to tap that destroy instead of wake up to the text message that you've got a billing alert because you're running some Kubernetes cluster you were playing for 5 minutes with. Uh, Looking for more questions, but I don't see any. I'll just the lab is on the GitHub. For no, I don't know if that's the question about November or not, but all our repos should be available on the DevOps Playground GitHub. We also have a do-it-yourself section when you can actually also make an environment for the labs. So the instances we provided, we will also share that. Today's lab, yeah, the uh, everything should be within the repo, which is on the video description. So the one I was following with the README here should be all the steps as well and the files. Um, cool. I don't see any more questions. It looks like we're almost destroyed. Cool, cool, cool. Well, the infrastructure is destroyed, so I'll take it as a sign. I don't see any more questions. Thanks a lot, everyone, for joining today. I hope it was useful and you learned something. What I was trying to, well, my message was experiment, use the services which are available and play around. And uh, yeah, that's more or less it. Thanks a lot again, and I'll stop the stream now.